So yeah, we are moving to our next session. In this session, we are going to see how to build your own AI support assistant using AWS Bedrock in minutes. To to take the session, we are having a speaker, Mrinal PR, who is a Site Reliability Engineer 2 from Guidewire Software, over 4 years of experience in AWS Cloud, DevOps and SRE.
Thank you all. So I know you might be a bit heavy after the superb lunch, so I will keep this short and we'll try to make it interesting. So today I'm going to talk about how we can build our own AI support assistant using Bedrock within minutes. So before I start, one key thing I want to emphasize here is you don't need to be an AI ML expert to play with these services. Even I have limited exposure to AI and ML, but still I'm able to build some cool things using these services. So it's so developer friendly. So we can just focus on our idea, and rest of the heavy lifting part is taken care by AWS. So in that note, I'm starting. So here is a quick look at what we'll cover today. So we'll start with an introduction to Amazon Bedrock. We'll see how Bedrock connects with multiple LLMs. And we'll see why context matters while working with LLMs. We'll see the concept of RAG, knowledge bases, Bedrock agents, guardrails. And finally, I'll walk you through a demo. So it's a recorded one, not a live. So let's start. Okay. So you can think Bedrock as your generative AI control center on AWS. So instead of building a model from scratch, Bedrock gives us access to one of the top leading models available in the market, like Claude, Llama, Nova, Mistral, etc. So you can build chatbots, agent search system, without need to worry about GPUs, scaling, or infrastructure. So everything is taken care by Bedrock. So we just need to plug in our data using knowledge base and RAG, and that's it. So we can see that in a minute in the upcoming slides. Apart from that, it's a fully managed, secure, and scalable service offered by AWS. Moving on. So now let's see how Bedrock talks to different LLMs. So as I said, Bedrock gives us access to many models like Claude, Llama, Mistral, and these are developed by different companies like Anthropic, Meta, AWS, and you have one question like how we can connect with these different LLMs developed by different companies. Bedrock solves this by one unified standard API, so that we don't need to change our request format to work with every model. So whether you are calling Claude or Llama, your request format remains the same. So the only thing we need to change is the model ID. So the one advantage here is it's easy to switch models, compare outputs, or upgrade. So let's say if a better model comes tomorrow, it is easy to switch. And the two core APIs exposed by Bedrock, the invoke model and invoke agent. So invoke model is used to send prompt directly to text model, and invoke agent, it is used to interact with Bedrock agents, and it can be used to much more like fetching our data from associated knowledge base and more. Moving on. Okay. Now let's see why context matters while working with LLMs. As you can see, I have two examples here. In the first one, I'm asking a question directly to LLM. What is the earn leave policy here? And it does have an answer, but it is a generic one because it doesn't know about our organization policy. So it's a generic one and it is not much useful for us. And in the second example, I've asked the same question, but this time with a clear context. So what is the current leave policy in my organization? And it responded with an accurate answer. So the key takeaway here is LLMs are powerful, but the context is what makes it even more powerful and useful for real-world scenarios. So now let's talk about RAG, or Retrieval Augmented Generation. So as I said, LLMs are smart, but they don't know about your own specific data. So RAG solves this by letting your model know about the real facts behind it with the associated knowledge base before answering the query. And RAG works in 3 simple steps: retrieve, augment, and generate. So in the retrieve step, the system finds the relevant information from your documents residing in S3, Confluence, SharePoint, everything. And in the next step, augment, it adds the relevant context that is retrieved from the previous step to the prompt. and it is sent to the model. And the final step, generate, so the LLM answers using its own knowledge plus the retrieved context. So the output or the response given from the LLM would be much more accurate and grounded to your own specific data. Moving on. So now let's talk about Bedrock knowledge base. So this is where everything we discussed so far comes together. So with knowledge base, you can give foundational models and agents the contextual information about your own data. So in that way, the response generated by the model would be much more accurate, relevant, and it should be customized as well. So we can build knowledge base in simple steps. So we can connect our data source. So it can be S3, Confluent, SharePoint, or even web crawler. And second step is to choose an embedding model. So we need an embedding model to convert our documents into vector embeddings because it is understood by the system and we can search the relevant context there. So I'm using Titan embeddings for that. It is built, it is easily integrated with Bedrock. And the last step, we need to store this generated vector embedding. So I'm choosing OpenSearch Serverless Service. It's an AWS offered service. So I'm using that one. So once this setup is ready, the knowledge base will handle like everything, like ingestion, retrieval, scaling, everything. So these all are ML terms, and we don't need to worry about all these things. It is taken care behind. Moving on. So now let's talk about Bedrock agents. So, so far we have discussed about chats only. So without any agents, the LLM can only chat. So if you need to do much more things like to take any action, to follow a structured workflow, we need agents to do that. And you can think of agent as an orchestrator that sit on top of LLMs. And using agents, we can use our knowledge base to answer accurately, call your APIs and tools like Lambda functions or other services. We can execute multi-step workflows. We can maintain conversational state for continuity. Moving on. Okay. So now let's look at the last part of this theory. So we talk about guardrails. So let's say we have a completely AI-ready system in hand. But imagine one user asking some irrelevant or inappropriate question to the model, and the model is free to answer those without any control. But that is not what we are expecting at an enterprise level. So guardrails act as a policy layer that we can apply on top of a model so that we can block harmful or toxic content using safety filters. We can mask personal identifiable information. We can restrict certain topics so that we can ensure our model is respond what it needs to respond. And we can say what are the restricted contents and it can block those things. So that's that. Now let's see how can we build our own AI support assistant. So this is an end-to-end architecture of what I've built today. So we have in the top left corner user or application, and in the central part we have the Bedrock agent here. So when a user asks a query through an application, the query comes to the Bedrock agent, and the agent determines what to do with the request. So it tries to fetch the relevant context from the associated knowledge base. And I have my sample data. It's some support-related text files that I've put in my S3. And using one embedding model, I've converted those documents into vector embeddings and stored it in the OpenSearch service vector store. So once a query is asked to the Bedrock fetches the relevant context from OpenSearch service, and the Bedrock agent creates an augmented prompt. So the augmented prompt is nothing but a query plus the retrieved context, which is rich in the information. And using that one, the LLM would be able to respond accurately, which is grounded to your own specific data and based on its own intelligence. So this is how the system works. Now let's see that in action. Can you play that? So here is in my AWS account, I have, sorry, the clarity is a bit low. So I have a sample text files, and it have a customer query, troubleshooting aid, etc. And I've put those data in my S3 And this is the Bedrock console. I'm creating a knowledge base here. I'm giving it some random name. I'm choosing that data source as S3. And I'm plugging in my bucket here. So this is where my data resides. This is the default. I'm going with all default settings. And I'm choosing one embedding model to convert to vector embeddings. I'm going with Titan embeddings. And I'm choosing one vector store to store those vector embeddings. And I'm creating that knowledge base. So I've chosen OpenSearch serverless as my vector store. So once you open this OpenSearch service, we can see our collections here. I'm not going so deep here. So we can see our vectors created as part of the ingestion process. So once our data source is connected, we need to sync. So this step is important because the data in S3 may change. So we need to resync those data to reflect here. So once it is ready, we can test our knowledge base from the Bedrock console itself. So let's say I'm asking one question by choosing one model. So I'm going with Nova, some kind of Amazon model. So I'm just asking, I forgot my password and I can't log in. So I have my related fix or support fix that resides in my S3. And the model responded accurately. And when you closely look at the details, we can see the metadata associated with that response. So this is the associated data chunk where the answers come from. So once our knowledge base is ready, we are okay to create agents. So I'm in the agents console. I'm giving it some random name. And I'm selecting the model. I'm going with Nova Premier here. And I'm giving some instruction for the agent. So it is just to clear what this agent would do. It can be in plain English. You don't need to worry about the coding steps here. So I'm just attaching my knowledge base here that is just previously created. And I'm giving the knowledge base instruction as well in plain English. Okay. So once it's ready, I've just saved it. And I need to prepare this model. Yeah. So once it is ready, now the next step is to create an alias. Alias is nothing but it's a stable version of what we are creating. We can create multiple alias and to compare models, to compare outputs as well. So I'm creating one. So once we create the alias, we have one alias ID and agent ID. And this is my sample Flask app. So I've put in that agent ID and alias ID here. And this is the core API I'm using, invoke agent, using those parameters. And I'm just running the application here. So this is my chatbot. And I'm giving some questions like my coupon code is not working. And I'm just opening, so the related context here. So when it is not working, either it should be coupon expired or the value is not met. So you can see that the model responded with its associated knowledge base that residing in the S3. Yeah, that's it, and I'm just giving it another try. It's something, my order package is lost. Yeah. So it did not to be in this format. So whether you have a meaningful text here, you can put it in S3 and you can do everything. So I've just followed a sample structure here, that's it. Yeah, cool. Yeah, that's it. Can you move back to presentation? Cool. So that's all about the demo. And here is a list of options that you can try to make it further. So maybe you can integrate the same thing with chat platforms like Slack or Teams. And you can enable email-based communication as well using SCS or Workmail. And one of the other option is to connect incident management tools. Like if any user requests with any support request, you can integrate it with tools like PagerDuty, Jira, or ServiceNow, and it can be taken further. So these are the other options maybe you can try. Yep. That's it, all about I want to say, and I'm open to any questions.
Guardrails are not, can you explain?
Yeah, actually, guardrails have not put in. Actually, at an enterprise level, we must need guardrails because we need to restrict certain topics. Like if this model is asking like, what is the score of cricket or what is your opinion about politics, the model will try to respond it. But we need to restrict those topics using guardrails. I've not included in that one, sorry.
But there is an option, that plugin is that option.
Yeah, yes, we can add it. Yeah. No, actually, it's act as a policy layer, like as a security layer. Like we can restrict such topics, or otherwise, let's say the model will try to respond to every answers. So our application or our product would be based on certain topics, right? So we can restrict the model to respond based on that topic only, and we can block other requests. Like as I said, I am using one support assistant here, and let's say one user is asking about cricket score or even politics. The model is not trying to respond it because it blocks it. So that's guardrails, like a policy. Correct, yeah. And we can configure in that a way, like, so I've chosen the model to respond based on its knowledge and the associated knowledge base. And we can restrict the knowledge base itself. Then it won't respond based on its general knowledge.
Any more questions? No, right? Yeah. Thank you so much. Thank you, Mrinal. Thank you for the wonderful session. Let me invite Sharika to